Okay, welcome to this video. We left off here on page 13. Move over to one page, page 14, and we're going to solve number 9. We've got three equations at the top. First thing, we have to fix this one. Total distance, d, is equal to the first subdistance traveled plus the second subdistance traveled, and you just add up however many individual distances are traveled. Now, we've got two other equations, and these equations have been adapted for the x-axis. Remember, we're doing one-dimensional motion, which means we're only moving along the x-axis, or we're only moving along the y-axis. So we could just as easily change this equation for the y-axis. Some problems will involve the y-axis, and for those problems, you'll have to change the equation. Okay. Number 9. The first thing we will want to look at is, are we dealing with the x-axis or the y-axis? A cat is initially standing 12 meters to the left of a pot. Look at that, to the left. That's the x-axis. Okay. Let's keep reading. The cat then walks 7 meters to the left, then walks 15 meters to the right, then stops to stare creepily at its owner, as cats are known to do. What's the cat's final position after stopping? Take the flower pot as the origin. The first thing we do after we figure out we're dealing with the x-axis is and so I can show x-axis if I want, as a way to remind myself. I'm going to remind myself that to the right is positive and to the left is negative. If this were a problem about the y-axis, I would have drawn something like this. Right? But it's not, it's the x-axis. The first thing I want to do is decode the problem and figure out what are the givens. The givens typically are values. So it says a cat is initially standing 12 meters to the left of a flower pot. That's a given. You've got 12 meters, which suggests you're either looking at a displacement here or a position. Now, position is about where you're located, where you are at a particular moment. Displacement is about how you've moved. Which one is this? Is this a position or a displacement? The answer is this is a position because you're initially standing. The cat is standing at the location. We're not talking about movement. We're talking about where the cat actually is. Okay, so let's write that down. The position is 12 meters. It says to the left, so we have to add a negative sign. 12 meters to the left of the flower pot, which is the origin. Okay, is this the initial or the final position? Well, the stuff that happens after the cat is standing here. So you've got this position, and then something happens later. That means this must be the initial position, x sub I. Okay, we move on to the problem. Then the cat walks 7 meters to the left. You see the word walk? That means this is a displacement. It's a displacement on the x-axis because we're dealing with the x-axis, not the y-axis. So what's the displacement? It's 7 meters to the left, they said. So I'm going to add a negative sign because it's to the left. This is the first displacement of 2, we're going to see. There's another displacement coming right after, so it's kind of a sub-displacement. Alright, then the cat walks, that's displacement, walks 15 meters to the right. So there's another displacement that occurs. It's 15 meters, and it's to the right, so I'm going to make this positive. Oops. Okay, and then they say, what is the cat's final position after stopping? They want me to find that final position, x sub f, after the cat stops. Making a list of givens and unknowns, this is the very first step after you've figured out if you're talking about x-axis or y-axis. This is a crucial step in solving because then we can figure out which equations will help us get to the unknown. Here the unknown is x final, so look at your equations. Which equation has x final? It's this one right here. There's x final. So we will have to use that equation to calculate x final. So you write the equation down. Even if it's shown right above, you write it again. Now to find the unknown, x final, here's the unknown. And I like to mark up my equations the way I'm showing you right now. I do this on my paper. To find x final, I need x initial, and look, I have it. There it is. But I also need the total displacement delta x. I don't have that yet, so let me go ahead and find what delta x is. How can I find it? Let me look at my equations. Here's another equation with delta x that if I can find delta x from this equation, I can plug in the value right there. So to get delta x from this equation, what do I have to do? I have to add up the individual displacements, the first displacement plus the second displacement. So what's the first displacement, delta x1? It's -7. What's the second displacement? It's +15. -7 and +15 make a +8, like that. So now I know delta x, I know this, I know x initial, and that's great because I only have one unknown in the equation. To solve the equation, you only can have one unknown. So let's plug in the values. Delta x we found was +8 meters. X final was my unknown. And x initial, what am I plugging in for x initial right here? Let's see, I'm plugging in -12. That's what my chart says. -12 meters. When you subtract a negative, it becomes positive. So I just made those positive, right? So I want to isolate x final, x sub f. And so how do I isolate it? Well, I have to get rid of the 12. We're adding 12 to the right side, so I get rid of it by subtracting it from both. 12 minus 12 goes away, that's 0. And x final is -4 meters. And that includes correct sig figs. Okay, now let's try number 10. You know what? Actually, let's switch to number 11. We're going to do 11 next. A dog and a cat are engaged in a friendly game of chase. The dog runs 6.3 meters rightward. First, that's to the right. We're dealing with the x-axis here, because right is on the x-axis. That's horizontal. Now this is a given. Is it the position or is it a displacement? It has meters, so it has to be one of the two. Well, we're talking about running, and so that means that's a displacement. It's 6.3 meters to the right. The right is positive. Okay. Then the dog runs 2.9 meters to the left. So that's another displacement. It's 2.9 meters to the left. And again, how do I know? I made it negative because it's to the left. But how did I know it was displacement, not position? Because they said runs. That's motion. That's movement. It's not just located 2.9 meters. It's running. It's moving 2.9 meters. And then it runs 1.4 meters rightward. Runs, that's another displacement. It's to the right, so I make it positive, and the distance is 1.4 meters. Exhausted, the dog lies down and is now located 1.8 meters left of a tree. So is it moving 1.8 meters or is it positioned 1.8 meters to the left? It is positioned or located 1.8 meters to the left. That makes this a position, 1.8 meters. But is it the initial position or the final position? The answer is this is the final position because that's where the dog is after these displacements. That's why it's final position, because this is the position after the displacements. All right, part A. Prior to running around, before the displacements, what is the position? They're asking us to find the initial position before those displacements occurred. So again, we think about our equations. You've got delta x equals x final minus x initial. you've got delta x equals delta x1 plus delta x2, dot, dot, dot. And you've got d, the total distance, is the first distance traveled plus the second, dot, dot, dot. Now we have to be tricky. We have to be careful. This is a 1, whereas that's an I. So those are two different things. Okay, we're looking for the dog's initial position. So what equation has initial position? It's this one. So let's write that equation down, because that's what we'll use to solve. So we're working backwards, you see. I'm looking for initial position, which means I'll need to know delta x and x sub final. I know x sub final. Here it is. It's 1.8 meters. How can I find delta x so that I can plug it into the equation to get x sub I? Well, how can I find delta x? I turn to this equation, because that's another one with delta x. That equation says, get the total displacement by adding the individual displacements. Like this. So what's the first displacement that we went through? It was, and there's 3 displacements. There's 3, so I'm going to need to add a third. I haven't given you much room to do this work on your page, so I actually might recommend getting a separate piece of paper out and then just putting that into the notes, adding it into the notes. So 3 displacements to add. The first was positive 6.3. The second was negative 2.9. And the third was positive 1.4. You can use your calculator, add those up, and what's the total displacement? This comes to a positive 4.8. And even though I left out units in my calculation, I do have to show the units in my final answer. But I'm running out of room, so I'm just going to put them on the next line. So positive 4.8 meters. That means on the whole, the dog ran 4.8 meters to the right. Okay, now that I know delta x, I can come back to this top equation. I plug in for delta x, it's positive 4.8. I plug in for x final, it's 1.8. That's what this says. So it's positive 1.8. Minus x initial. I don't plug in for x initial because that's my unknown. I'm trying to find it. To find x initial, we have to get it by itself in the numerator. That's what isolating is. But right now we're subtracting it, so it's like a negative x sub I. Before we do anything else, let's make this a positive x sub I. I'm going to do that by adding x sub I to both sides. Okay. Plus x sub I. And now the left side is x sub I plus 4.8. The right side, negative xi plus xi is 0. So all we have left on the right is 1.8. Next, I subtract 4.8 from both sides in my quest to isolate xi. And x sub I comes to a negative 3.0. Now, if you got positive 3.0, that's because you didn't consider this negative sign right here. We're subtracting xi, so we need to make xi positive, change this to a positive. And I did that by bringing xi to the other side. So there's the answer. Initially, the dog is 3 meters to the left, negative, to the left of, what's the reference point? The tree. The tree is the origin. So initially, the dog was 3 meters to the left of the tree. Part B, what's the total distance the dog travels? Well, the total distance, you take the first distance plus the second, plus the third, dot, dot, dot. We only have 3 in this case, so you add those distances up. And remember, distance can only be positive, so I'm taking absolute values. The first distance the dog traveled was just 6.3 meters. The next displacement, the displacement was negative 2.9, but you have to take away the negative sign because the distance was just a positive 2.9. And then the last displacement of the dog was 1.4, so you make that positive, which it already is. You add these up, and what do you get? The distance is 10.6 meters. Alright, that's how you solve these problems.